Milestones review, lesson 9 is systems of equations. Number 1, what is the solution to the system of equations shown below? The solution to a system in a graph is where the two lines intersect. So that would be 4, comma, negative 3. That means that 4, comma, negative 3 is a solution to both of the equations involved. Question number 2. Is the ordered pair 5, comma, 23 a solution to the system of equations? To determine this, we have to substitute the ordered pair into both of the equations to see that it works for both of them. So let's start with the first one. Y equals 4x plus 3. Y is 23. X is 5. Now we just have to solve it. Bring down the 23. 20 plus 3 is 23. So we get a yes on this one. The next one, y equals negative x minus 2, is the same idea. So we're going to substitute 23 equals negative, and then substitute the 5, minus 2. So we have 23 equals negative 5 minus 2 is negative 7. That is not true. So that is a no. Because of that, this system is not, or this solution is not a solution to this system. Question number 3. What is the system of equations shown in the graph below? This is where you simply have to write the equation for both of the lines because that's the system. We're not looking for the solution, we're looking for the system of equations. Let's look, and we're going to use y equals mx plus b. So let's look at this first equation, or the first line, and we need to find the b. The b is going to be positive 4. The slope is negative, so I'm going to make sure I put a minus sign for the slope. And then I need to find another point on the line, and I'm going to use this one, which is the actual solution. So I can count 1, 2, 3, 4, 5. 1, 2. So I have negative 5 over 2. So my first equation is y equals negative 5 over 2x plus 4. Here's my second line. It is a horizontal line. And if you remember the cheer, y graph like this, x graph like that. We know this is a y equals a number, and that number is going to be negative 1. So our other equation is y equals negative 1, and that would be our system. Question 4. Which equation can accurately be substituted into the first equation of this system? So we're going to look at this equation because it's saying which equation could be accurately substituted into the first one, which is 5x minus 4y equals negative 3. So for this second one right here, we're going to solve for y equals and check it, and then we're going to solve for x equals if we need to, because we have a and b are both set y equals, c and d are both x equals. So let's solve for y equals first. 3x plus y equals 5. Minus 3x minus 3x. Draw a line and cancel. So we have y equals negative 3x plus 5. So let's look. Answer choice A, we have negative 3x and a positive 5. So that one looks good. B, we have a positive 3 and a negative 5, so that one is not what we needed. Let's look at solving for x values. So we're going to do the same thing, except we're going to solve for x. 3x plus y equals 5. So this time we're going to subtract y on both sides. So we get 3x equals negative 1y plus 5. Divide by 3. And I'm going to come up here to write my equation. X equals negative 1 over 3y plus 5 thirds. Now let's look at our answer choices. On either one of those, that looks like what we have. Those are eliminated. Our answer would have to be A. Question 5. What is the solution to this system? So we're going to have to use substitution method. Later you'll be able to use the elimination method, but for this one we're going to substitute. So that means we have already gotten one that is solved for x or y, and it's solved for y. So we're going to circle it and make a connection to the y in the other equation. So now we can start to solve. Negative 3x minus 3, and instead of putting y, we're going to put what we're saying y equals, which is negative 5x minus 17, and then finish the equation with equals 3. We only have one variable, which means we're going to get an answer. We're going to solve for the x variable first. We have to distribute, and you need to be careful because you have to distribute the negative as well. So I'm going to bring down the first negative 3x, and now I'm going to distribute. Negative 3 times negative 5x is positive 15x. Negative 3 times negative 17 is positive 51. And then I bring down the equals 3. Now I can combine like terms. I see that I have two x values that I can combine because they're on the same side. Negative 3x plus 15 is going to give me positive 12x. And I'm going to bring the rest of the equation down. Now I can subtract 51 from both sides. So I'm going to have 12x equals 3 is positive, 51 is negative, so I know it's going to be negative, and it would be 48. So now we need to divide both sides by 12. Divide by 12. So x equals negative 4. And we can put that in our answer box that I'm making right now, that x equals negative 4. Now we have to find the y value, so I'm going to take the equation that is equal to y. That is a 17. And I'm going to substitute in our negative 4. Now I can solve it. And my y value is going to equal 3. I can put that in my answer box, and I am finished. Question 6. How many solutions? We're not looking for what the solution is. We just want to know how many there are going to be. And we know if it has one solution, no solution, or infinite solutions, we need to look at what the graph would look like, what the m and the b are. So for this one, we already have it solved in slope-intercept form. So we know the m is negative 3 and the b is negative 2. So I'm going to solve the second equation for y actually. So 9x plus 3y equals negative 6. We're solving for y. So I'm going to subtract 9x from both sides. Then I'm going to bring down the 3y, and I have negative 9x minus 6. I'm not finished because I'm still wanting to solve for y. I'm going to divide everything by 3, and I will have y equals negative 3x minus 2. So let's put that up here next to the equation, negative 3x minus 2. And let's look at our m's. Our m's are both negative 3x, and our b's are both negative 2. So we have the exact same equation once we solve them for y. So when you have the exact same equation, you're going to have the exact same line. They will be coincidental lines. So it will have an infinite amount of solutions because the lines are intersecting the entire time. Question 7. Write a system of equations for the following situation. Randy earns $15 per hour. That per hour is important. And has already saved $100. And Cameron earns $10 an hour and has already saved $500. So we have two situations. We have Randy and we have Cameron. And we're going to substitute in the n and the b so we can write equations. So Randy's equation is going to be 15x plus 100. And Cameron's equation is going to be y equals 10x plus 500. So that would be our system of equations for the situation. Then we're going to go to question 8, which is directly related. After how many hours will Randy and Cameron earn the same? The same, you should automatically think of the equal sign. And then we want to know what will that cost be. So we have Randy's equation, and we're going to set it equal to Cameron's equation. So we can find out when they will be the same number. And remember, we're looking for the cost. So let's start to solve because we're going to solve for x. I'm going to subtract 100 on both sides. And I have 15x equals 10x plus 400. I'm going to subtract subtract 10x on both sides. So I have 5x equals 400. So I can divide by 5, divide by 5. So my x is going to be 80. And the x value represents hours. So it will be the same after 80 hours. But then the second question says, what will the cost be? So the x value is the time, the y value is going to be the cost. So it's a system, so we're going to pick one of the equations. I'm going to choose Cameron's equation. And we have an x value now, which is 80. So we can substitute in and solve for the total cost. 10 times 80 is 800 plus 500. I'm sorry, it is 8. Okay, I thought I messed up. But this is 80. And we want to make sure that we have 80 because that's our x value. So we have y equals 800 plus 500. When you add those together, you get 1,300. So let's summarize what we're answering in our question. After how many hours will they be the same? After 80 hours is the first part of the question. And then the second part of the question, what will that cost be? The cost will be $1,300.